Hello dear students, this is the lesson number 7 of quadratics for AS levels. In the first 4 lessons, we established our concepts regarding quadratics. We understood the graph of the two different cases. Case 1 when coefficient of x square was positive, case 2 when coefficient of x square was negative. Then we discuss the solutions of a quadratic equation, two real and different solutions, two equal solutions, and no real solution. 3 cases we discussed, and we discussed the relation of these 3 cases with the discriminant of a quadratic equation. Then we solved a linear equation and a quadratic equation simultaneously, and then we learned about solving quadratic inequalities. After that, in the last 2 lessons, we solved some exam-based question to prepare ourselves to go to the past year exams questions. This is the last lesson. I have picked some questions from past year questions which will inshallah cover each and every type of questions for you. Let us solve these questions one by one. Question number 1. Find the value of constant c for which the line y is equal to 2x plus c is tangent to the curve y square is equal to 4x. Line is y is equal to 2x plus c and curve is y square is equal to 4x. Now this line is tangent to this, means if we will solve these two lines, these two equations simultaneously, we will get only one solution. For that, we will put the value of y from this linear equation into this equation. 2x plus c whole square is equal to 4x. Now we will formulate a quadratic equation in x. In order for the line to be tangent to the curve, this quadratic equation must give us only one solution. For that, we will put its discriminant equal to 0. Let me rearrange this line. 4x square plus 4 times c minus 1 into x plus c square is equal to 0. Its discriminant will be b square minus 4ac, which will be 4 times c minus 1 its square, which is b, minus 4 into a into c. This must be equal to 0, which implies 16 into c square minus 2c plus 1 minus 16c square is equal to 0, which further implies 16c square minus 32c plus 16 minus 16c square is equal to 0. We will get 16 is equal to 32c and c is equal to 1 over 2. So this is our value of c which was required. This was the first question. Let us move to our second question. Again, a line is given y is equal to 4x plus k. K is unknown. We have to find the value of this constant k. It does not intersect this parabola. Line equation of line is y is equal to 4x plus k and equation of curve is y is equal to x square. We will put this value of y over here. 4x plus k is equal to x square minus 4x minus k is equal to 0. Does not intersect the curve. It means it will have no solution, which means this quadratic equation's discriminant will be negative. So let us put the discriminant equal to negative. Discriminant is equal to b square minus 4ac, which is minus 4 square minus 4 into a into c. This should be negative. 16 plus 16, 4k should be equal to, should be less than 0. 4k is less than minus 16. K is less than minus 4. This is the set of values of k for which this line will not intersect this curve. This was the second question. Let us move to third question now. Same sort of question. I have arranged these questions by myself. Now again a line is given and it is told that it intersects this curve at two distinct points. First question was the line was tangent to this curve. So we put the discriminant equal to 0. Second case, line did not intersect the curve. In that case, we put the discriminant less than 0. And in this case, line intersects at two distinct points. It means there will be 2 points of intersection for this line and the curve. Line is equal to kx minus 4 and curve is y is equal to x square minus 2x. Put the value of y over here. Kx minus 4 is equal to x square minus 2x, which implies x square minus 2x minus kx plus 4 is equal to 0. X square minus 2 plus k into x plus 4 is equal to 0. Now, discriminant must be positive, that is b square minus 4ac must be greater than 0. That minus negative 2 plus k, its square minus 4 into a into c should be greater than 0. 4 plus k square plus 4k minus 16 is greater than 0. K square plus 4k minus 12 is greater than 0. This is a quadratic equation. Coefficient of k square is positive. So its graph will be like this. Refer to the first lecture of quadratics. It will be positive before its smaller root and after its larger root. So we will find its roots. I am factorizing it directly. You can add on a few steps. So two roots are minus k and 2. Minus 6 and 2. This is minus 6 and this is 2 suppose. So this is positive before minus 6 and positive after 2. So what will be the values of k? K will be less than minus 6 or k will be greater than 2. Any value less than minus 6 or greater than 2 when put in this equation, the line obtained will intersect this graph at two distinct points. I hope it is clear. Now we are moving to our next question. A curve has equation y is equal to kx square plus 1 and line has equation y is equal to kx, where k is non-zero constant. Find the set of values of k for which the curve and line have no common points. It means when we solve these two equations simultaneously, there will be no intersection point. I refer to the first lesson, to the lesson in which we solved a linear and quadratic equation. When we solve a linear and quadratic equation, we put the value of y in the quadratic equation and we get a quadratic equation in x. That quadratic equation in x will give us either two real values or two equal real values or no real value. If this line and this curve has to be no common point, then the equation formed in x will have no real solution or its discriminant will be negative. So let us solve this. Line is y is equal to kx, curve is y is equal to kx square plus 1. I am putting the value of y over here, kx square plus 1, 0 is equal to kx square minus kx plus 1. Since they have no common point, this quadratic equation's discriminant will be negative. So I am putting that discriminant d is less than 0, that is b square minus 4ac is less than 0, k square minus 4k is less than 0, k into k minus 4 is less than 0. This is 0 and 4 are its solution. K is equal to this. Since k coefficient of k square is positive, so this will be negative between the roots. 0 is less than k is less than 4. These are all possible values of k for which they will have no solutions. Second point, state the value of k for which the line is tangent to the curve. Okay, if this line is to be tangent to this curve, then this quadratic equation will give equal roots. For that, this discriminant must be equal to 0. And for that, k will be 0 and 4. So these are values of k and for which the line becomes tangent to this curve. Also find the coordinates of point where line touches the curve. So when k is equal to 0, y becomes 0, line becomes 0, and for k is equal to 4, line becomes 4x. This was the equation of line. Okay, when k is 0, putting in quadratic equation, 0 is equal to kx square plus 1. So 0, when k is 0, 0, 1 is the intersection point, and when k is equal to 4, y is equal to kx square plus 1 gives 4x is equal to 4x square plus 1, 4x square minus 4x plus 1 is equal to 0. It means 2x minus 1 whole square is equal to 0, x is equal to 1 by 2. Second intersection point is 1 by 2, and put 1 by 2 over here, x, y will be 2. Putting x is equal to 1 by 2 we will get. So these are two intersection point for two different values of k. This was the third question. Let us move to our next question. Now we move to our next question. The straight line y is equal to mx plus 14 is tangent to this curve y is equal to 12 over x at the point P. Find the values of the constant m and the coordinates of point P. This is the line and this is the curve, and it is given that this line is tangent to this curve. With the help of this information, we will first find value of m. Y is equal to mx plus 14 and y is equal to 12 over x plus 2. I will put the value of y over here. Mx plus 14 is equal to 12 over x plus 2 multiplied with x. Mx square plus 14x is equal to 12 plus 2x. Mx square minus plus 12x minus 12 is equal to 0. For line to be tangent, b square minus 4ac is 0 implies 144 plus 48 m is equal to 0 implies m is equal to minus 3. This is the first result. By putting m is equal to minus 3, the line becomes y is equal to minus 3x plus c, and curve becomes y is equal to 12 over x plus 2. Now, by putting m is equal to minus 3 over here, we will get the quadratic equation minus 3x square plus 12x minus 12 is equal to 0 implies 3x square minus 12x plus 12 is equal to 0. And what we will get? We will solve for x. 3x square minus 6x minus 6x plus 12. and this will be 3x into x minus 2 minus 6 into x minus 2, 3x minus 6 into x minus 2, and we will get basically both the values of x will be 2 by putting x is equal to 2 over here. The line was y is equal to minus 3x plus 14. For x is equal to 2, y is equal to 8. So 2, 8 is the point of intersection. I hope it is clear. Let us move to our next question. This is the last question for today. A curve has equation. This is the equation. First of all, we have to find the set of values of it for which this curve is greater than 9. 2x square minus 3x is greater than 9, or 2x square minus 3x minus 9 is greater than 0. Coefficient of x square is positive. So graph will be of first time and curve will be greater than 0 beyond its roots. For that, I will solve this equation first. You have different options to solve this equation. You can use the quadratic formula, you can choose to complete the square, or you can make the factorization. I am making the factorization over here. I am making the factorization over here. I am putting this equal to 0. Two x square minus 3x minus 9 is equal to 0. 2x square minus 6x plus 3x minus 9 is equal to 0. 2x into x minus 3 plus 3 into x minus 3. So two roots are minus 3 by 2 and 3. So this will be positive when x is less than minus 3 by 2 or x is greater than 3. This is the answer to our first question. Second part was, express this in the form a times x plus b square plus c, where a, b, c are constant, and state the coordinate of vertex of this curve. 2x square minus 3x. 2x square minus 3x. First of all, what we have to do, we have to take out 2, x square minus 3 over 2x. Then we have to add and subtract the square of half of this. Half of minus 3 by 2 is minus 3 by 4. So I will add the square of minus 3 by 4, which is 9 by 16. And I will also subtract the same. So what did I get? I will get first 3 term will give me x minus 3 by 4 square minus 9 by 16. This will be 2 times x minus 3 by 4 square minus 9 by 8. Its vertex will be at x is equal to 3 by 4. When we will put 3 by 4, then 3 by 4 minus 3 by 4 will be 0. So minimum value will be minus 9 by 8. So this is the vertex of the parabola. We learned this in lesson number 3. What was the third part? The function f and g are defined by f of x is same, 2x square minus 3f, g of x is equal to 3x plus k, where k is constant. Find the value of k for which the function g of f of x has equal roots. F of x is equal to 2x square minus 3x, and g of x is equal to 3x plus k. 3x plus k. What will be g of f of x? This will be 3 times f of x plus k, which is equal to 0. 3 times f of x is 3 times 2x square minus 3x plus k is equal to 0. 6x square minus 6x plus k is equal to 0. This is the quadratic equation formed, and it is given that this has equal roots. It means for the roots to be equal, discriminant must be 0. So we will put the discriminant b square minus 4ac is equal to 0, minus 6 square minus 4 into a into c is equal to 0. 36 minus 24k is equal to 0. It means k is equal to 3 by 2. Dear students, that was all for today's class. I chose these questions very carefully. By solving this question, it will become very easy for you to attempt any questions from quadratic section. Please subscribe my channel to get the timely notifications of upcoming videos, and also share with other students so that they could also benefit from this. Stay tuned. Allah bless you.